Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to talk to you about functions and graphs. Now the question that I've chosen to go through here is 2018 Paper 1 Question 8. In this question we're introduced to the function c of t, where c of t represents the number of units of a particular medicinal drug that remains in the bloodstream t hours after you've taken it. So t represents the number of hours after you've taken this drug. C of t represents the number of units in the bloodstream. They've asked you to verify that after 4 hours, the amount in the bloodstream is 224. So I think it's important to actually write out the information so you're clear on what you're trying to do. So that means that you have to sub into your function. Instead of a t, you're going to sub in 4. If everywhere there's a t, you sub in a 4, you manipulate it down, and you end up with 224. So I know that after 4 hours, there's 224 units of this drug in the bloodstream. Okay, now part B here is relatively straightforward. We're still using the same function we were given in the first part of the question, and we're given a number of different values for t ranging from 0 to 9. We're asked to find the corresponding values of c of t. In other words, for example, if I know t equals 2, in order to find the corresponding value, all I need to do is I sub into this line, except instead of minus t cubed, it would be minus 2 cubed, and then plus 4.52 squared, plus 54 multiplied by 2. And if you plug that into your calculator, you get 118. So you just plug in 2, 3, 4, 5, 6, 7, 8, 9. You plug in each value, and these are the answers you should get for your units. For example, I know that after 8 minutes, the units is after 8 hours, the units is 208. And now we can use these are all coordinates. For example, this is the coordinate 0, 0. This is my x, this is my y. This is the coordinate 1, 5.75. So we have 10 different points here. We can use these points now to plot our graph for part C. Okay, so for part C now, we just need to use our values from part B. Remember, your t values will be along the horizontal line, or the x-axis, and the amount of the drug, or the units in this case, will be along the y-axis, the vertical line. So my first coordinate was the coordinate 0, 0. It's just going to go there. My next coordinate was the coordinate 1, 57.5, and so on. You just plot your 8 different coordinates. Now your graph will probably be a little bit more accurate than mine. Once you've got those tables and you've got those boxes, you are expected to be very accurate. So you draw your graph like that, and then you're going to use this graph in order to answer the questions to part D. Now for part D, it says to use the graph from part C to estimate 2 different things. Now because the question says use your graph, you have to show on your graph how you found your answers. So for example, D part 1, it asks me to use my graph to estimate the number of units after 3.5 hours. So what I need to do is, the hours are along the x-axis, so I go to 3.5, obviously halfway between 3 and 4, and if I'm using my graph, you need to use a ruler. Since I'm doing this on glass, I'm going to estimate it. So you need to use a ruler and draw a broken line up to your graph. Once you get to your graph, you then draw a broken line across. You just work across, and when you do that, the answer should be 200 units. So obviously my graph is not as accurate as yours will be because mine is on glass, but the answer in the marking scheme in this case is 200 units. So your answer there, depending on how accurate your graph was, you should be getting roughly 200 units. Now for D part 2, it has asked me to estimate how long it will take for the units in the bloodstream to be 100. So in this case, I've been given the units and I need to find the time. So in this case, I start at units are 100, that's clearly the y-axis. I go to my 100, and again, you should be using a ruler. You use a broken line to draw your graph, and then you go down. And depending on how accurate your graph was, the answer in this case should be 1 hour and 45 minutes. So based on your graph, it should have been 200 units for D part 1 and 1 hour and 45 minutes for D part 2. Okay, the rest of this question is all to do with the theory. In E part 1, it asks me to work out the rate at which the amount of drug in the blood is changing. The rate at which one thing changes relative to another is differentiation. So basically this is just a jazzy way of asking you to differentiate. Your function is minus t cubed plus 4.5 t squared plus 54t. They just want you to get the derivative. So to get the derivative of this, I just bring the power in front, so it becomes minus 3, and then I decrease the power by 1. 3 minus 1 gives me 2. In this case, I have a 4.5 at the start, then I bring the power in front, so it's 2 times t, and the power decreases by 1. 2 minus 1 gives me 1. In this case, I just bring the power in front. 1 by 54 is still 54, and the power of t decreases by 1, so it becomes t to the power 0. If I just simplify that, it's minus 3t squared. 4.5 by 2 is 9, and that's a t, and then the t to the power 0 is just 1, so I didn't even need to put in the t to the power 0. Your derivative there is just this in the box. Okay, e part 2 is just a direct continuation on from e part 1. If I know the rate at which the drug is changing is this, that's obviously in terms of t. If I want to work out the rate at which the drug is changing after 4 hours, instead of a t, I sub in a 4. When you do that, you end up with 42. So I know the rate at which the amount of drug in the bloodstream is changing is 42 units per hour after 4 hours. So 4 hours after I take this, there's an extra 42 units of this drug going into my bloodstream every hour. Okay, for E part 3, it asks me to use my answer from E part 1 in order to work out the maximum amount of the drug in the bloodstream over the first 9 hours. So they're asking you to find the maximum point on the graph. The maximum point, that means the first derivative equals 0. In order to identify a maximum point or a minimum point, you let the first derivative equal to 0. And in E part 1, we worked out that the first derivative was equal to this. So in order to solve this, in order to identify where the maximum amount of drug in the blood was, I need to let the first derivative equal to 0, and I'm going to try and solve it to find the value of t. So this is my first derivative, I let it equal to 0. So that will allow me to identify the max point. I don't want to factorize a quadratic with a minus in front of it, so I've just changed all my signs. It becomes plus 3, minus 9, minus 54. Now when you get numbers like that, you'll never really be asked to factorize something that difficult, so always look for a common factor. In this case, you can just divide everything by 3, and your quadratic actually becomes just t squared minus 3t minus 18. And this one is a lot easier to factorize. In order to factorize this one, I need the factors of 18 that have a difference of 3. Numbers that multiply to give me minus 18 but have a difference of 3. In this case, clearly the numbers I'm going to be looking at are 6 and 3. I want my factors to add up to minus 3, so it's going to be minus 6 plus 3. Minus 6 multiplied by plus 3 gives me minus 18, and if I add minus 6 and plus 3, I get minus 3. So happy days, I've identified my factors, I can just write them in. The factors of t squared are just t and t. The factors of minus 18 that I'm going to use are minus 6 and plus 3. So they're my factors, but obviously that's not what I'm looking for. I'm looking for the actual values of t. In order to find the values of t, I just need to let each one of these equal to 0. I can let t minus 6 equal to 0, which means that t is equal to plus 6, or I can let t plus 3 equal to 0, which means that t is equal to minus 3. Now it doesn't make sense to say that the amount of drug that will be at a maximum 3 hours before you take the drug. So it doesn't make sense to have a negative value there, so I can ignore it. I now know that 6 hours after I take the drug, that is when the amount of drug in the bloodstream will peak. So I know the maximum point is when 6 hours after I've taken the drug, which means that in order to work out how many units of drug are in the bloodstream at this stage, you need to sub back into your original equation. My original equation, which was the equation for C of t. So let's just do that now. So I know that 6 hours after I've taken the drug, there'll be 270 units of it in my bloodstream, and that is the maximum amount, because after that stage it's going to start decreasing. I'm going to start metabolizing it. Okay, the final part of this question asks me to prove using my derivative from E part 1 that the amount of drug in the bloodstream is decreasing 7 hours after I've taken the drug. So in order to do that, I need to, our derivative from E part 1 is this. and I need to work out what is the rate of change of the drug after 7 hours, so I sub in a 7 instead of a t. And in that case, your answer works out as minus 30 units per hour. So 7 hours after you've taken the drug, it starts to decrease in your bloodstream. Your explanation there, all they're looking for there is that the rate of change is negative. In other words, because this is a negative answer, that means that the amount of drug in the bloodstream is decreasing 7 hours after you've taken the drug. Mathematically, you could write that as C-T, the derivative is less than 0. If you just indicate that, then you're fine for your marks. So I hope all of that video makes sense. If there's anything you're unsure of there, or you want me to clarify something, just send me an email or let me know in class, and I'll try and explain it a little bit differently.